On April 6, 2026, 4 people flew around the moon. They spent 7 hours at the windows of the Orion spacecraft, taking turns, passing cameras, calling out features to each other and to mission control, 240,000 miles away. They photographed craters older than anything alive on Earth. They watched a solar eclipse that lasted 54 minutes. They saw 6 meteoroid impacts in real time. And for 40 minutes, they had no contact with home at all. These are the images they brought back. Not rendered, not simulated. Taken by human hands through spacecraft windows with handheld cameras. I've gone through the full set. Here's what stood out. This is what Earthset looks like from lunar orbit. April 6th, 2026, 6:41 p.m. Eastern Time. The Artemis II crew watched their home planet sink behind the rim of Ohm crater. A complex impact structure with terraced walls and central peaks formed when liquefied rock splashed upward on impact. The clouds you see are over Australia. The dark side of Earth is in night. And from this distance, that thin bright arc is everything you've ever known. Quiet. The Terminator. Not the movie. The line where lunar day meets lunar night. At this angle, sunlight barely grazes the surface, and everything changes. Craters that would look flat under direct light suddenly have depth. Ridges cast shadows for dozens of kilometers. Burkhoff, Stebbins, Joule. Structures you'd never notice under full illumination. Revealed only when the light comes in sideways. 3 hours into the crew's observation window. Far side of the moon. Orion, fully sunlit, with the moon behind it. First quarter phase, light from the right. Near the bottom edge, a dark patch. That's Orientale Basin. Ancient lava, sitting inside a 600-mile-wide impact crater ringed by mountains. Orientale straddles the boundary between the near side and the far side. Most people have never seen it from this angle. Now 4 humans have. 6 minutes before Earthset. Earth in crescent phase drifting behind the limb of the moon. Sunlight from the right, nighttime on the left. Those faint lines on the lunar surface, the small chains of indentations, are secondary craters. Debris ejected from a primary impact, landing in sequence. The moon keeps a record of its own violence. We just happen to be close enough to read it. The crew described it themselves. The Terminator is anything but a straight line. Crater rims catch sunlight like islands surrounded by darkness. And stretching across the surface, giant chains of craters radiating from Orientale Basin, 3.7 billion years old. But look at what they're cutting through. Hertzsprung Basin. Flat, broad, scarred by the Orientale debris. Which means Hertzsprung was already there when Orientale happened. Older than 3.7 billion years. That's the kind of detail you read in geology, not in headlines. South Pole-Aitken Basin. The largest impact structure on the moon. The oldest. The eastern edge, heavily cratered, with the Terminator cutting across the top of the frame. Billions of years of geologic history compressed into one view. No spacecraft with humans aboard had ever photographed this terrain from this angle before April 6th. 3 objects in one frame. Orion, sunlit, on the left. The moon, waxing crescent, behind it. And then, just barely visible near the moon's limb on the right, Earth. A crescent, tiny compared to the moon, about to set below the lunar horizon. 6:42 p.m. Eastern Time, day 6 of the mission. 1 minute after the Earthset image. Same moment, wider perspective. Everything you know, reduced to a sliver of reflected light. This is the image that stopped me. A solar eclipse, photographed not from Earth, but from lunar orbit. The moon backlit by the sun, captured by a camera on Orion's solar array wing. Orion itself in silhouette on the left. But look closer. The left edge of the moon is slightly brighter. That's Earthshine. Light bouncing off our planet, faintly illuminating the lunar surface from behind. The bright point below the moon's lower right edge. Saturn. The one at the far right of the frame. Mars. 2 planets, a star, a moon, and a spacecraft. 1 exposure. 54 minutes. That's how long totality lasted from this position. On Earth, you get 2, maybe 4 minutes if you're lucky. Here, the moon is close enough and large enough to block the sun completely for nearly an hour. The glowing halo around the dark disk. The science community is still working on what exactly that is. Corona, zodiacal light. Possibly both. The caption was updated 2 days after release. They're still analyzing. And the faint features you can make out on the moon's near side. That's Earthshine again. Our planet, lighting the moon from 240,000 miles away. Partial frame. Only a section of the moon visible as it blocks the sun entirely. That bright silver point at the left edge, Venus. And between the 9 and 10 o'clock positions on the moon's limb, a round, dark gray feature. Mare Crisium. A lunar sea you can see with your own eyes from your backyard. Photographed here from the other side. Same feature. Opposite perspective. And then, this. 4 astronauts in eclipse glasses. The same glasses NASA produced for the 2023 annular eclipse and the 2024 total eclipse. Koch, Hansen, Wiseman, Glover. Floating in microgravity, wearing cardboard eclipse viewers at the moon. The first time that's ever happened. There's something about that image that doesn't need narration. Earthset again, but from a different angle. Same time, 6:41 p.m., Orientale Basin on the limb. And inside the frame, Hertzsprung. 2 subtle concentric rings, barely visible unless you know what to look for. A younger crater, Vavilov, punched right through the older structure. Layers of time superimposed. The moon doesn't erase its history. It stacks it. More than 2/3 of the moon in a single frame. The near side, fully lit during the first observation shift. Orientale Basin on the boundary between near and far sides, sometimes partly visible from Earth, depending on libration. Northeast of it. Grimaldi. A round black spot. Exceptionally dark lava floor, heavily degraded rim. One of the darkest features on the entire near side. You can find it with a small telescope. But not like this. Orion in sunlight again, waxing gibbous moon behind it. But the framing here matters. Orientale sits near center bottom, and it splits the view. Everything to the left of that basin is the far side. Everything to the right is the near side. The hemisphere we never see, and the hemisphere we see every night, divided by a 600-mile scar filled with ancient lava. One image. 2 halves of a world. 3 minutes. That's how long before the crew went behind the moon and lost contact with Earth. 40 minutes of radio silence. No signal, no telemetry, no voice from home. This was captured at the edge of that window. Earth setting, Australia visible through the clouds, Ohm crater in the foreground with its terraced walls and central peaks. The last thing they photographed before going dark. 3 minutes of connection left. Then nothing but the far side. Vavilov crater. Close-up handheld camera, 400 millimeters focal length. On the right, smooth material inside an inner ring of mountains transitioning to rugged terrain at the rim. Long shadows at the terminator stretching across the surface. This was shot from the far side. By hand. From a moving spacecraft. The detail is almost geological survey quality. 36 minutes before Earthset. The moon fills most of the frame. Earth. A crescent, off to the right, in the blackness beyond the lunar limb. Orientale Basin dominates the lower third, its dark lava floor showing different colors that hint at mineral composition. And somewhere in this image, two craters the Artemis II crew has proposed names for: Integrity and Carroll. Not yet official. But if approved, the first features named by humans who saw them in person since Apollo. Victor Glover, pilot. Looking out the Orion window, headset on, face lit from below. 7 hours. The crew spent 7 hours taking turns at those windows, capturing science data and photographs. At closest approach, 4,067 miles from the surface. This is what that distance looks like from inside. The eclipse ends. The sun begins to emerge from behind the moon's limb. A sharp sliver of light after nearly an hour of totality. Just the edge of the lunar disk visible in frame, and where the sunlight breaks through, it catches the topography along the limb. Ridges and valleys that are normally invisible, revealed for a few seconds by the geometry of reemergence. Then gone. This is how those images were made. Jeremy Hansen, camera pressed against a shroud covering window 2. The shroud, essentially a curtain with a hole for the lens, blocks cabin light from reflecting off the glass. No studio setup. No tripod. A human, a camera, and a curtain between them and the moon. 9 minutes before Earthset. Shot through the Orion window. And you can see it. The window frame, slightly blurred in the foreground. The moon sharp filling the view. And behind it, a tiny crescent Earth about to disappear. This isn't a processed image from an external camera array. This is what the crew saw, with their eyes, through glass. Same moon. Different aperture setting. Smaller opening, less light. And the result is this. A darker, moodier version of the Nearside. The familiar features are still there. Orientale, the Mare, the bright crater spots. But underexposed, they feel different. Quieter. Like the moon when no one is looking at it. Close-up of the Nearside as Orion approached. The dark patches. Ancient lava flows, billions of years old, cooled and solidified across vast basins. And near the top of the frame, a bright white dot sitting in the middle of a dark gray flow. Aristarchus crater. One of the brightest features on the entire lunar surface. Visible from Earth with the naked eye on a clear night. From 4,000 miles. It almost glows. Glover and Cook. Working the windows in near darkness, cabin lights off to reduce reflections. The only illumination. The glow from a device screen and whatever light the moon itself sends back. 7 hours of this. Coordinated shifts, choreographed handoffs. Not a photo session. A science operation. 3:41 p.m. Eastern. The concentric rings of Orientale Basin. One of the youngest large impact structures on the moon and one of the best preserved. Scientists use these rings to model how massive impacts reshape planetary surfaces. And at the 10 o'clock position, 2 smaller craters. The crew has proposed names for them. Integrity and Carroll. Crew identified features named in real time during a flyby. That hasn't happened since the Apollo program. Meanwhile, on the ground, mission control. The White Flight Control Room at Johnson Space Center. 3 science officers monitoring data in real time from the science console. Garcia, Young, Graf, the first science officers of the Artemis program. 10 minutes before Earthset. The crew is about to disappear behind the moon. These are the last people who can talk to them before the signal goes dark. Orientale again, but closer. The rings filling the entire frame. Concentric circles of displaced rock from an impact so massive it created a structure 600 miles across. The crew kept coming back to this feature. Multiple images, multiple angles, multiple shifts. When something is this well preserved after billions of years, you document it. The eclipse image. Again, a second exposure from Orion's camera, nearly identical framing. The moon backlit, Earthshine on the left edge, Saturn below, Mars at the far right. The fact that NASA released multiple versions of this frame tells you something. They're still studying it. The halo, the light distribution, the corona question. This image isn't closed yet. Hertzsprung Basin. 2 concentric rings of mountains visible from above. The signature of an ancient massive impact. Lower left. Vavilov, identifiable by its central peak. The crew kept returning to this region throughout the flyby, calling out features, recording observations. The same structures, seen from slightly different positions as Orion moved along its trajectory. Reed Wiseman, commander. Beginning his first observation shift. Face lit by whatever is coming through the window, headset on, looking up. The astronauts aren't just passengers on this mission. They're members of the science team. The data they collected during these hours will shape lunar research for years. The final wide view of the sequence. Just over half the moon, nearside facing the camera. The dark lava patches across the upper third. Orientale at center, wrapped in mountain rings, black lava in its basin. Grimaldi, the dark round spot to the northeast. Aristarchus, that bright white point, still glowing in the middle of a gray lava flow. Every feature we've been talking about in one frame. A summary the moon wrote for itself. Midway through the observation period, the camera turns around. Glover, Hansen, Wiseman, Koch. 4 people inside a capsule smaller than a minivan. 240,000 miles from home. They look tired. They look like they know exactly where they are. 2:19 p.m. Eastern, just before the observation period officially began. Orientale center frame. The black lava patch at its core, where magma punched through the crust billions of years ago. 600 miles across. And to the left. Byrgius. A small, bright crater with rays extending 250 miles outward from its basin. Impact ejecta frozen in place, radiating like a signal no one turned off. The sun rises behind the moon's edge. The eclipse is over. For nearly an hour, the crew had the moon in darkness, a perfect opportunity to look for things you can't normally see. And they found them. 6 impact flashes. Meteoroids traveling thousands of miles per hour, hitting the lunar surface while the crew watched. Light from collisions happening in real time. They called it down to Earth at 9 p.m. Eastern. 6 flashes. That data is new. The last wide shot of the nearside. More than 2/3 of the disk. Orientale on the boundary. Grimaldi, dark and worn, to the northeast. The same features, one more time. But by now, after everything the crew documented, you see them differently. Because now you know what you're looking at. Jeremy Hansen, Canadian Space Agency. Mission Specialist. Face lit by green instrument glow. Cabin dark around him. 4,067 miles from the surface at closest approach. He looks like a person who just saw something he'll spend the rest of his life trying to describe. Orientale. Again. The crew's most photographed feature of the flyby. And for good reason. 600 miles across, ancient lava at its center, concentric mountain rings around it. Every pass, a slightly different angle. Every angle, more detail. This crater is a textbook written in rock. They kept reading it. This is a cross-section of lunar geology in a single frame. Aristarchus, bright, high reflectivity, standing out against everything around it. The Marius Hills, volcanic domes and cones, evidence of a moon that was once active. Reiner Gamma, a swirl pattern that still doesn't have a fully agreed upon explanation. Rays from Glushko crater streaking across the plains. And Grimaldi, dark floored, anchoring the bottom of the frame. 5 distinct geological features. 1. Photograph. The last image. Not the moon. Not the crew. The engines. Orion's service module. The orbital maneuvering system engine at center. 8 auxiliary thrusters around it. The hardware that brought them there and will bring them home. Shot from a camera on the solar array wing. The machine, alone against the black. 39 images. 7 hours of observation. 4 crew members. 1 day at the moon. Most of what you've just seen was taken with handheld cameras through spacecraft windows, using a curtain to block cabin reflections. The science officers on the ground were watching in real time. The crew proposed names for craters they identified during the flyby. They documented a solar eclipse from a perspective no human had ever occupied. They recorded meteoroid impacts on a darkened moon. And the data from this one day, one flyby, is still being analyzed. The halo around the eclipsed moon. The mineral composition hints in the Orientale lava. The crater chains that rewrite the timeline of lunar impacts. The images are public. They're on NASA's servers. Anyone can look at them. Most people won't.